So in this video, we're going to go over encryption algorithms, especially DES and triple DES. You obviously know a little bit about encryption already. Obviously, it's used to sort of hide data and make things unreadable. You will need to talk about it a bit more technically in this. I was going to say technicality, but technically in this. Now, a lot of encryption algorithms tend to use tend to have data that's encrypted, but it uses a key. Now, the key is used for encryption and decryption at the same time. So you encrypt data using the key, you send the key along with the data, and then somebody can unlock it. Obviously, there are some barriers you need to overcome with that, because potentially somebody could steal the key halfway through, or obviously intercept the data with the key. It could be that you give keys out beforehand, and then when you send data, you've already got the keys and stuff like that. So depends on numerous different factors, but generally it tends to have a key that you use to encrypt and decrypt. Now, obviously, with using keys, there's two types: there's symmetric and asymmetric encryption. Now, symmetric encryption is the one I've just described, where it's like you will encrypt the data. You will send it through the internet or network or whatever you're sending it through, and then decrypt it with the same key when you get to the recipient. So sender, encrypts the data, sends a key along with it, and then your receiver decrypts the data with the same key. So that's symmetric encryption, because it's literally the same key. However, there's another one, which is asymmetric encryption. Now, this uses two keys, and your sender and your receiver both have keys, but they're mathematically paired. So they're not exactly the same, but mathematically they are. Now, the good thing with this is, because you're not having to send keys across, and they're paired, technically it's a lot more secure than a symmetric encryption. However, with using keys that are mathematically paired, there's more of a case for people to potentially pretend that they've got another key that is mathematically paired. It is more secure in terms of the keys, because the keys are mathematically paired in such a way, it should be impossible to replicate. Technically speaking, it is possible to replicate one of the keys that's mathematically paired to one another, but the odds of actually making a key that is mathematically paired to it is literally trillions upon billions to one. So obviously that's negligible. A computer's never going to figure it out in time. It'd probably take a decent computer years to work that out, and at that point the data is useless. So really, this is the safer method than using symmetric encryption. Because obviously symmetric encryption is like this graphic on the bottom, where you got say a file, you use a key to obviously encrypt it, and then you send the cipher across, so basically the encrypted text or an encrypted document or whatever, with the key, and then you decrypt it to the side. Prone to people hacking in or stopping it halfway through transmission and basically opening it up and see what's inside. It's still secure, because it even though it's got the key with it, depends on how a network's set up, because again, you could say that the key has to be used in a certain way. Essentially, how keys work is on mathematics. So it might be that the key has to have a certain equation attached to it in order to decrypt the file. Now, if you're sending that online, it might be that the person who intercepts the file and the key cannot decrypt it, because they haven't got the right encryption/decryption algorithm with the key. Whereas obviously the two people sending between them might. So it is a little bit more secure than just, because it's pointless, obviously, encrypting the data, sending it across, and then somebody grabbing it anyway, because then what's the point of encrypting it in the first place? So there is a little bit of security there, but it's better with asymmetric encryption, and we'll go over that in a separate video. But that is what symmetric encryption is. Now, as for one encryption algorithm, so DES, DES was used quite a few years ago. So it was data encryption standard. It was used or made by IBM, and essentially what this did was use a block cipher stream of about 56 bits in length. So it would encrypt each bit of data by 56 bits, and then encrypt it, send it along its way, and then have it be decrypted. Now, in the 70s, that was brill. Like, nobody could obviously decrypt that because of the computing power available. But from today's standards, unfortunately, it's not very secure, so it's not really used anymore because the key length is actually quite small. You'd be surprised 56 bits is quite small for a key length. The minimum really is now like 64 bits and beyond. You're getting up to 256 bits, if not nearly a megabyte, in encryption length. So this is quite small. However, there is another one that they brought out called triple DES or 3DES. It depends on who you ask. I'd call it triple. So basically, it does 3 keys for each of the 56 bits now. So instead of just having 1 key, it has to have 3. And that's obviously a lot more secure because if you lose 1 key, you still can't decrypt the data. You need all 3. So it's currently not been cracked as of yet because obviously it uses the 3-key system instead of 1. It's mainly because it's quite secure now. It's using a lot of bank transfers and stuff like that, or paying while you're using PIN numbers and stuff like that if you're in a shop. So it's used quite a lot for financial systems because of how safe it is. Now, basically the way it works is it takes each bit of data and it basically encrypts it 3 times, so with 3 keys. So it encrypts it once with a key, encrypts it again with another key, and then encrypts it again with a 3rd key. And then obviously it decrypts it on the way back through in order to make it back into plain text again. So this graphic where it's in a loop, that's 1 to encrypt it and then 1 for decrypt. And the -1 just means basically the opposite. If you do know your maths, that means that it's 1 over DS. But anyway, I digress. So that's the way to sort of decrypt it back. It basically encrypts it 3 times in order for it to be more secure. So if you do have 1 key, it's not going to make a difference because you still can't decrypt it. So that's why it's called triple DS, because it uses 3 keys in order to encrypt it. So that's a quick look at symmetric and asymmetric encryption. I will go over asymmetric encryption in another video because that's not really for this one. But you will need to talk about DES and how triple DES is a lot more secure than the original DES. So please have a look into it. Obviously, use these resources. Have a look online as well. If you've got any questions, I can answer them. So yeah, make sure you talk about these and make sure you also talk about how symmetric encryption works as well.